We now have all of the tools that we're going to get for factoring a polynomial. We should try our basic techniques first, because when they work, they're the easiest way. Then, well, sometimes we'll start out knowing a complex root. This might come from something about how we set up the polynomial. It might come from some other numerical techniques that are outside the scope of this course. Either way, if we know a complex root, we should start with the corresponding irreducible quadratic factor, divide by that. Whatever's left, we'll use Descartes' rule of signs to analyze its real roots. Then we'll try rational roots until we get down to a quadratic factor, or until we've eliminated all the possibilities. Once we get down to a quadratic factor, well, we know all about quadratics. We can use the AC method, we can try completing the square, or we can use the quadratic formula. Any of those methods will give us the last two roots. So let's go through an example with the whole process. Here we have a polynomial. We'll try the old techniques first, but this has 5 terms. None of our old techniques work for something with 5 terms. Do we know a complex root? Yeah, we do know a complex root. So we'll start by finding the irreducible quadratic factor that goes with that root. So we have one complex root, that means we have 2 complex roots. We have 3 minus 2i. We also have the plus version of that. To get the irreducible quadratic factor, I think the easiest way is to think in terms of roots. So we're going to add 3 to both sides of this, square both sides. So we've got x squared plus 6x plus 9, 2i squared, positive or negative doesn't matter. It's negative 4. So x squared plus 6x plus 13 is 0, is the quadratic that has those roots. X squared plus 6x plus 13 is a factor. Now we'll divide by that, making sure my terms are in order and I don't have any gaps. I have an x to the 5th. Oh, I don't have an x to the 4th term, so I'm going to fill in a 0 x to the 4th. I have a minus 14 x to the 3rd. I have a minus 26 x squared. I have a 105 x. And I have a minus 26. Again, I have to use regular polynomial long division because I'm dividing by something with an x squared in it. So, x squared goes into x to the 5th, x to the 3rd times, x to the 3rd times x squared is x to the 5th, x to the 3rd times 6x is 6x to the 4th, x to the 3rd times 13 is 13x to the 3rd. And now we subtract. So, negative 6x to the 4th, negative 14 minus positive 13. Be careful here. We have minus 27 x to the 3rd. And then we'll bring down our negative 26 x squared. First terms again, negative 6x to the 4th divided by x squared is negative 6x squared. Multiply. Negative 6x squared times x squared is negative 6x to the 4th. Negative 6x squared times positive 6x is negative 36 x to the third. Negative 6x squared times positive 13, you might want to grab a calculator for this one, is negative 78 x squared. I did not just do that in my head. I worked this out earlier. And now we subtract. Get 0 here, 9x to the third. Negative 27 minus 36 is positive 9. Negative 26 minus negative 78 is positive 52. So we have a positive 52 x squared. And now we bring down the 105x. First terms again. 9x to the third divided by x squared is going to be plus 9x. 9x times x squared, we've got 9x to the third. 9x times 6x, we've got 54x squared. 9x times 13, we've got 117x. Subtract one last time. We've got a negative 2x squared minus 12x. Bring down the negative 26. First terms, one last time. Negative 2x squared divided by x squared is a negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 6x is negative 12x. Negative 2 times 13 is negative 26. And we get no remainder, as we knew we wouldn't. If we got a remainder at this stage, we've made some sort of a mistake, because we knew that this was already a factor. So far, we've factored our polynomial as x minus our original imaginary root, x minus its conjugate, times now this new degree 3 thing, x to the third minus 6x squared plus 9x minus 2. Okay, all we have left to do is factor that degree 3 part. We're down to something with 4 terms, so we might try grouping. Grouping isn't going to work in this. Kind of the obvious way to group this is just throw the terms in order. But then I've got an x squared here, and an x here, and a 9 here, and a negative 6 here. Oh, 9 times negative 6 is definitely not negative 2. I could try swapping this around. Maybe I want to put the x to the third with the negative 2 and not the negative 6x squared. Oh, but then I just have a 1 here. I'd need an x to the third here, and that's not going to work because that's not a factor of 9x. Or I could try putting the x to the third with negative 2 and not with 9. X to the third with negative 2 and then put the 9x over here. Yeah, that's not going to work over here. Because here I've got an x squared, which means I need an x here. But again, that's not a factor of the negative 2. Grouping does not work. So I want to go to the rational roots. We're going to use Descartes' rule of signs to analyze this guy. So we've got x to the third minus 6x squared plus 9x minus 2. That's going to be 1, 2, 3 sign changes. So we'll have 3 or 1 positive roots. If I plug in negative x, that's going to reverse the sign of everything with an odd power of x. Negative x to the third minus 6x squared minus 9x minus 2. Oh, every term there has a negative coefficient, so no sign changes. That means I'll have 0 negative roots. So that means I only have to try positive numbers. That's pretty cool. We're factoring x to the third minus 6x squared plus 9x minus 2. That means our p is a factor of 2, plus or minus 1, or plus or minus 2. Our q, our leading coefficient is 1. Our q is just 1. That makes our life easier. So our possible rational roots are plus or minus 1 or plus or minus 2. Put that together with the fact that there are no negative, and our possible rational roots are just 1 or 2. Okay, I can handle that. I can do synthetic division with 1 and 2. So I'm going to try 1 first. Our coefficients, we've got a 1, a negative 6, a 9, and a negative 2. Drop down the 1. 1 times 1 is 1, plus negative 6 is negative 5. Times 1 is negative 5, plus positive 9 is positive 4. Times 1 is 4, plus negative 2 is 2. We got a remainder. 1 is not a root. 2 is the only possibility left. Let's try it. Our coefficients again are 1, negative 6, 9, and negative 2. Drop down the 1. Times 2 is 2, plus negative 6 is negative 4. Times 2 is negative 8, plus 9 is positive 1. Times 2 is positive 2, minus 2 is 0. Okay. 2 is a root. We got factors x minus 2 times x squared minus 4x plus 1. That last one's quadratic. I can see the AC method isn't going to work. I'm going to try completing the square because that looks easy. Subtract the 1 on both sides. Actually draw my square over here. I've got an x squared. I'll split my negative 4x in half. So that means I've got an x times x, a negative 2, and a negative 2. I need a 4 here, so I'll add 4 to both sides. X minus 2 squared is 3. That means x minus 2 is one or the other of the square roots of 3. X is 2 plus or minus the square root of 3. Okay, let's collect this all. Our roots, we were given minus 3 minus 2i. Then we knew minus 3 plus 2i must be a root because it's the conjugate. We found 2 by trial and error. And then we found our last 2, 2 plus root 3 and 2 minus root 3, by completing the square. And notice, these are both positive, right? Square root of 3, that's less than the square root of 4, so that's less than 2. 2 minus something less than 2 is still positive. So those are all of our roots. Our factors, because remember we wanted both the roots and the factors. We have x minus negative 3 minus 2i, x minus negative 3 plus 2i, x minus 2, x minus 2 plus root 3, and x minus 2 minus root 3. And we have now factored this polynomial fully. We notice it had degree 5, and we successfully found 5 roots, 5 factors, just as predicted by the fundamental theorem of algebra.